Okay, now let's check our next question. 4.2. Given the geometric series 15 plus 5 plus 5 over 3 plus so on. Okay, now our first question says explain why the series converges. Remember, converges must think of what? The value of r. Okay, so now let's try and calculate the value of r. Our r will be 5 divided by 15, term 2 divided by term 1, which is our r is equals to 1 over 5. Can you see our r is more than -1 but less than 1? That's why it's converging. Okay, so now let's check our next question. 4.2.2. they gave us a sigma, so it's n is equals to 1. Then they gave us infinity sign, 5 into the raised to the power of 2 minus n. So we're looking for what? For sum to infinity. Once you see something like this, we're looking for sum to infinity. So you don't need to calculate the number of terms that you're adding. So the only thing that we have to do now is to take this n and substitute. Start with 1, 2, 3. We need our first 3 terms. So now let's check when now n is 1, so we'll have 5, 3 to the power. Is it the same pattern or what? 2 minus 1, which is 15. Let's check when we substitute 2, 5. Okay, so it's same pattern. So our sum to infinity will be equals to a over 1 minus r. Our a is 15 over 1 minus 1 over 5, which is equals to 15 over 1 minus 1 over 5, 75 over 4. So that's our sum to infinity. Sum to infinity. Okay, next question. 4.3. The sum of the first n terms of a sequence is given by, remember we said when you see something else, you must remember where Tn is equals to Sn minus 1. Okay, so the sum of n is equals to 2 to the power of n plus 2 minus 4. First thing they're saying, determine the first question. 4.3.1. 4.3.1. determine the sum of the first 24 terms. Okay, that's nice. Sum of 24, where you see n, put what? 24 plus 2 minus 4. Let's check what to be our answer. 2 to the power of 24 plus 2 minus 4. What is this? 67,108,860. That's the sum of the first what? 24 terms. Then they're saying what? Determine the 24th term. Okay, term number what? 24. How do you get term number 24? We say sum of 24 minus sum of n minus 1, sum of 24 minus 1, which is sum of 23. So now we need what? Sum of 23. So now let's get the sum of 23. Sum of 23 will be equals to 2 to the power of 23 plus 2 minus 4, which is 33,554,420. 28. So now our T24 will be equals to the difference between those two values. T24 is equals to 67,108,860 minus 33,554,428. And what is the answer? Okay, what is the answer? So our answer is 33,554,432. Okay. Our next question, they're saying prove that the nth term of the sequence is 2 to the power of n. Okay, the nth term, Tn. They're looking for Tn. Okay, so now let's try and prove that. Tn is equals to our Sn. Let's write our question 4.3.3. 4.3.3. Our Tn, our Sn is 2 to the power of n plus 1 minus 4 into. Then now, how do you get Sn minus 1? Sn minus 1 is the same as 2 to the power of n minus 1. Why did I say minus 1 here? Plus 1. Okay, let's correct this one. This is plus 2. Okay, then let's correct this one now. 2 to the power of n minus 1 plus 2, then minus 4, which is 2 to the power of n plus 1 minus 4. So now let's substitute this thing here. So minus what? 2 to the power of n plus 1 minus 4. Now let's open our bracket. We'll have 2 to the power of n plus 2 minus 4 minus 2 to the power of n plus 1 plus 4. Minus 4 plus 4, 0. Then we're left with 2 to the power of n plus 2 minus 2 to the power of n plus 1. Okay, so we see a common factor of 2 to the power of n plus 1. 2 to the power of n plus 1 into. Okay, so now if I remove n plus 1 here, I'll be left with what? 1. So it will be 2 to the power of what? 1. If I remove this thing, I'll be left with what? With 1 straight. So it's minus 1. Therefore, the n, my Tn will be equals 2 to the power of what? N plus 1. Then finish though. Okay, thank you. See you next time. This is Mr. Tankal signing out. Thank you very much. Take care.